Concept 26.3 says shared characters are used to construct phylogenetic trees. So let's get into kind of the nitty-gritty of how we actually construct one of these charts or diagrams that shows this phylogeny. Once homologous characters have been identified and they've been separated or distinguished from analogous ones, they can be used to infer a phylogeny, an evolutionary history, or kind of a stream that we can follow. One approach is called cladistics. Cladistics uses common ancestry as the primary criterion to classify organisms. So cladistics groups organisms by common descent. And a clade, which obviously comes from the word cladistics, a clade is a group of species that includes an ancestral species and all its descendants. And there's a variety of ways we can kind of chop this tree up and look at it, and that's what we're going to do. So a clade is a general term that describes a group of species that includes an ancestral species and then all of the descendant species. Clades can be nested into larger clades, but not all groupings of organisms qualify as a clade. So again, a clade is a general term. A valid clade is described as being monophyletic. Monophyletic signifies that it consists of one of an ancestor species and all the descendants. Monophyletic comes from a Greek word meaning single tribe. So if you actually want to describe a grouping as a true clade, that would be the ancestor species and all of its descendants. And again, this terminology is man-made. It's just another way of kind of dividing and subdividing all the groups of living creatures we see around us. So let's talk about cladistics a little bit, and I'll show you some examples. So in our first example, we have a true clade, a monophyletic group. This monophyletic group, they're just calling it group 1 or group I here. It consists of 3 different species showing, and this shows the ancestral species plus all of the descendants. So this would be monophyletic group, a true clade. Recall that monophyletic means single tribe, or comes from the Greek word single tribe. Another way of looking at that, another example, would be a paraphyletic. A paraphyletic grouping consists of ancestral species and some, but not all, of the descendants. Paraphyletic comes from the Greek meaning beside the tribe. So here's an example of a paraphyletic grouping. This will be group 2 that we're looking at here. This would include the ancestral species and then some, but not all, of the descendants. This would be a paraphyletic group. And there'd be different reasons we might want to group them in different ways like this when we're talking about the evolutionary history and comparing one to another. And again, like I've mentioned, keep in mind that this is a man-made type of grouping, just a way for us to kind of understand things and to study things. The last type of grouping is called a polyphyletic grouping, and a polyphyletic grouping consists of various species with different ancestors. So this one's different than the other two because this one is of various species with different ancestors. Polyphyletic from the Greek meaning many tribes. So here's an example of a different type of grouping we could do. They call this group 3, and it contains species A, B, C, and D. And notice that it is a variety of species, but they have differing ancestors. They don't all come from the single common ancestor. D comes from a separate ancestor back here. Now, of course, you go back far enough, and of course they do have a common ancestor way back here. But as far as where the grouping is concerned, they are coming from different ancestors. Consist of ancestral species, consist of various species with different ancestors. So here's kind of a summary of them all together. The one on the left here would be the only one that you would really truly call a clade. It's a monophyletic grouping, has the ancestral species and all of the descendants. Then we have a paraphyletic grouping, that would be the ancestral species with some but not all of the descendants. And then we have a polyphyletic grouping, which would be a variety of species from numerous ancestors, different ancestors like this in this case. And again, just different ways of looking at it. You would do this for a variety of reasons depending on what you were studying or how you were grouping the creatures. And this is called cladistics. It's just another method of grouping and organizing the living creatures in a certain way. When you are looking at any one particular animal, you kind of tend to look up and down the line. So you look backwards in time at its history, and then if it's a creature that, say, you're looking at a fossil, you may also look forward in time, almost to the present day, perhaps, to see what its history is as well. Now, of course, with existing species that are around right now, we can't look forward in time, we can only look backwards. But if you're looking at a previously existing species, potentially you have the possibility of using fossil and molecular data to look both directions. In comparison comparison with its ancestors, an organism has both shared and different characteristics. And an example is that all mammals have backbones, but a backbone does not distinguish mammals from other vertebrates because all vertebrates have backbones. Contrast that with the fact that hair is a character shared by all mammals but not found in their ancestors. So hair is specific to the mammals, whereas the backbone is not. In this case, the mammalian backbone would be called a shared ancestral character. It's a character that originated in an ancestor of the taxon that we're looking at. So mammals have backbones, but so do a variety of other creatures that have that same shared ancestor. So in a mammalian backbone, we would call that a shared ancestral character. Now, the mammalian hair does designate that particular taxon as different or separate. We would call that a shared derived character. It's an evolutionary novelty unique to a particular clade. So mammals alone have hair, and that makes it a shared derived character. Now, the particular trait or characteristic or character you're looking at could be considered ancestral or derived depending on the context or depending on the point on the phylogenetic tree that you're examining. Say, for example, we're saying if we look at the clade of mammals, we're looking at that grouping of all mammals, well then a backbone is an ancestral shared character and hair is a derived character. But if we were talking more specifically about a smaller grouping, say for example we're talking about primates, well, if you were talking about primates, well then hair would be considered an ancestral character as well, because all primates have hair. And they all have hair because all primates came from an ancestral common ancestor that had hair. So it depends on where you are. Are you at the very tip of the twig? Are you back further along one of the big branches? The character you're looking at could be an ancestral character if you're looking one direction, a derived character if you're looking another. You'll notice that basically what we're doing is we tend to start with the largest groups and we tend to get smaller and smaller and smaller down to a specific creature, a specific species. This is very useful, or a good way to do this is to use some of those evolutionary relationships and trying to figure out in which clade a shared derived character first appeared. If we know when a certain characteristic first appeared and then we know that got passed on to all the other descendants, that kind of helps us determine where certain things branch on these phylogenetic trees. So we can use that information of these various derived characters when they first appeared to infer evolutionary relationships. In the textbook it uses a great example of kind of starting off with a large group and then going down smaller and smaller and smaller. So if we were going to look at this group of creatures here, and we'll discuss what some of these terms mean like outgroup, but we have a shared ancestor among all of them, and then we have this one, the lancelet here, who is going to be called our outgroup, which we'll discuss why he's called our outgroup in just a moment. He does not have a certain characteristic of all the rest of them. If we come down here, we have a vertebral column. All of the creatures from the lamprey down to the leopard have a vertebral column. The lancelet does not. He is our outgroup. He is our outlier amongst all of those. And then we can start to look at other characters and we can get more and more clearly defined as we go. So all of these from the lamprey on down have a vertebral column. And then how about a hinged jaw? Where did the hinged jaws come into place? Well, that would be between the current bass and lamprey, the common ancestor at this point. So the lamprey doesn't have a hinged jaw, but all of these guys do. How about four walking legs? How about an amnion, which is basically the covering or the sac that the embryo develops in? And then finally down to hair. So we can get more and more and more specific, and we can look at some of the various characteristics, and that helps us determine sort of an evolutionary pathway along the way until we get to our leopard that we're looking at, who has all of these traits on down the line. So that's one way of doing it, is to look at these derived characteristics. Let's take a look at what outgroup and ingroup means, because you'll notice you see that here on the chart. An outgroup is a species or potentially a group of species that's closely related to the ingroup, the various species being studied. So the ingroup is kind of the group of creatures we're looking at, and the outgroup is another species or another group that's related to that, but the outgroup has diverged before the ingroup that we're looking at. So take a look at our lancelet in our illustration. So here we are, we're looking at all these creatures, and they are all somewhat closely related. They all have this common ancestor back here, but this one diverged prior to all the rest. So this is kind of our outlier, and he kind of starts off the domino effect. He is the one that does not have what all the rest have, and then we can start basically checking them off one by one and getting more and more specific to describe any one of these creatures. Systematists will compare each in-group species with the out-group to differentiate between the shared derived and shared ancestral characteristics. Characters shared by the out-group and the in-group are ancestral characters that predate the divergence of both groups from a common ancestor. So if you want to look at a character that's shared by the out-group and the in-group, well, that's an ancestral character that predates the divergence. So if we look at the fact that all of these have a spinal cord, which they do, the lancelet and all of these creatures have a spinal cord, well, that must have occurred prior to what we see on our chart here. That was present in their common ancestor. And then we start to get divergence with a vertebral column, a vertebrae, a hinged jaw, 4 walking legs, and on down the line. So comparing our in-group species with our out-group gives us kind of a starting point to then start to get more and more specific to see what is the relationship between these creatures. Now up to this point in all our phylogenetic trees, remember we've said that the length of the line doesn't really tell us much. We shouldn't infer any sort of time frame, or we shouldn't infer any information other than a basic relationship that we see within these lines. Now in some cases we do create phylogenetic trees that have proportional branch lengths, and we do link it to actual time frames, and that's what we're going to look at next. So for the moment, why don't we take a quick break? We'll come back and look at phylogenetic trees that actually have a time frame and certain years involved in them, and how they're perhaps a little bit different than the ones we've been looking at so far. Take a break, be right back.